So here's a big question for you. Can artificial intelligence actually predict the future of our climate? And I'm not talking about some vague global forecast. I mean a really specific prediction for a single region decades from now. This is, one of the biggest challenges in climate science, and today we're going to see how a brand new AI approach is tackling it head on. So in this explainer, we're going to follow a really fascinating piece of research that does just that. We'll start with the huge problem climate scientists are facing and end with a surprisingly clear peek into the future of rainfall, all thanks to a pretty clever combination of AI models. All right, first up, what is the big problem here? Why is it so incredibly hard for us to get a clear picture of our future climate, on a local level? Let's get into it. Our story starts right here in southern Thailand's beautiful and absolutely vital TSS River Basin. Now, this is a place where life really revolves around the seasons. About half the land here is used for farming, which means predictable rainfall is everything. It's essential for the local economy and, of course, the food supply. And this brings us to a really critical question, not just for the farmers here, but for communities all over the world. How can you possibly plan for the future? I mean, building infrastructure, managing your water, planting crops. How do you do all that when you don't really know what the weather's going to look like? Well, the issue is that our best tools for predicting climate change, these massive things called general circulation models, they operate at an incredibly low resolution. Imagine a map where just one single pixel covers hundreds of kilometers. It's way too blurry to tell a farmer what's going to happen in their specific valley. Okay, so how do you take that blurry global forecast and somehow make it sharp enough for just one neighborhood? Well, this is where artificial intelligence finally steps in. The answer is a technique called statistical downscaling. It's a really clever way of teaching an AI to find all the hidden connections between that big, blurry global data and the super detailed historical local weather. It's almost like having an AI that can take a pixelated image and intelligently sharpen it into a crystal clear photo. To do this, the researchers basically put together a team of digital detectives, 6 different machine learning models, and each one has its own unique way of thinking. See, they didn't want just any answer. They wanted to find the absolute best tool for the job, and that meant putting all of them to the test. So, they set up a challenge, a real machine learning showdown. They unleashed all 6 of these models on the historical data to see which one could most accurately predict local rainfall from the past, as a test for how well it could predict the future. Now, for your typical everyday rain, the results were pretty good across the board. On this chart, that black line, that's the real-world observed data. And you can see how all those colored dots, those are the model's predictions. They're clustering pretty close to that line. So for average weather, the AI was definitely on the right track. But, and this is a big but, here's the twist. When it came to the weather that matters the most, those extreme, intense peaks of the monsoon season, most of the models just fell apart. This chart here shows the error rate, and for a lot of them, the errors were huge. It turns out predicting an average day is one thing. Predicting a potential disaster is a whole other ballgame. This failure, though, it led to the paper's central insight, the real breakthrough moment. What if the best solution wasn't a single jack-of-all-trades model, but a specialist team of 2, where each one is designed for a completely different task? Let's meet our first specialist. This is long short-term memory, or LSTM for short. This type of AI is fantastic at understanding sequences and time. It's just perfectly suited for recognizing that long, steady, predictable rhythm of a typical year's weather patterns. And now for our second specialist, genetic programming, or GP. This AI is fascinating. It basically works like natural selection, creating and testing generations of solutions to evolve the perfect answer. This makes it incredibly skilled at tackling specific, really complex, even chaotic events, like a monsoon. So here's the crucial point. Think of the long short-term memory model as the marathon runner, perfectly paced for that long, steady, dry season. And then you have genetic programming. That's your sprinter, an explosive specialist built specifically to predict those short, intense bursts of the monsoon. And this chart just illustrates the result brilliantly. See that black circle on the right? That's reality, the actual observed rainfall. The other circles, those are the AI models. The closer a circle is to the black one, the more accurate it is. Now look at that dark purple circle, the one labeled LSTM GP. It's almost a perfect match. By combining their strengths, this specialist team became the most accurate forecasting tool of them all. So now for the main event. Armed with this incredibly powerful new forecasting tool, the researchers could finally ask the big question: what does the future actually hold for the TSS Basin? Okay, so the combined model predicts pretty minor changes in the near future, the 2030s. But then, things start to change. Towards the middle and the end of the century, the model projects a really significant and accelerating increase in rainfall, especially during that critical monsoon season. Right, let's focus on what happens in a high emissions future. That's a scenario where greenhouse gas emissions keep going at a high rate. During that critical monsoon season, from October to December, the changes are, well, they're dramatic. By the 2060s, rainfall could jump by over 93%, and by the 2080s, the numbers become truly staggering. To put a single number on the most extreme projection, we're talking about a potential 138% increase in rainfall during the 3 wettest months of the year. That's more than double the rain that these communities are prepared to handle today. Just stop and think about what that really means for fields, for homes, for infrastructure. And this isn't just some abstract academic exercise. As the researchers themselves say, having this kind of precise, localized forecast is absolutely essential. It's essential for managing water, for protecting communities, and for ensuring food security for millions of people. So the key takeaway from all this amazing research is that the answer isn't always a single perfect AI. By cleverly combining the unique strengths of 2 specialist models, we can move from a blurry, uncertain guess to a much, much clearer picture of what's coming. And that leaves us with one last provocative thought. For the first time, we have tools that can let us see the future with this kind of local detail. So the question is no longer just if we can see it coming. Now that we can, how are we going to prepare for it?